Welcome to our course of Autodesk Robot SAP 2016, Advanced Level, for Buildings Design, Wind Loads, and Seismic Analysis. Allow me to demonstrate you. Here we've a project that was generated in Autodesk Revit. But now, it will be our task to take this model, and obtain the structural project. So to begin with, here we've already the analytical model for this project. Nevertheless, we haven't really created this analytical model from scratch. Just by opening this project into Revit Structure, and applying the template structural privileges, we've automatically obtained this analytical model. And this analytic model can be verified for preventing any possible inconsistencies. Namely, that from the lines of this model, and the lowering of loads, to the supports on the extremes, all of them are uniform, not showing any conflicts that could cause a calculation error. Furthermore, Revit Structure already allow me to perform the loads assignment, as well as the combinations, but also, reviewing the supports. So Revit Structure is indeed a quite competent software, which needs almost nothing, but to perform the calculation. However, once we've obtained this analytical model, now perfectly reviewed and verified, we can then export it into Autodesk Robot SAP 2016. Therefore, during this course, we'll observe specifics about importing models between Revit Structure and Robot SAP. So once we've opened the model into Robot, it's still possible to obtain some errors or warnings. Therefore, another part we'll observe is how to either correct or avoid such errors, hence obtaining an analytical model ready for analyzing. Here for example, we can observe our same model, but with all the components properly assigned to each level in the project. Now, talking about levels, here we've what refers to the slabs, and in this regard, we might be asked to modify the monolithic or two-direction slabs, for orthotropic ones, namely, slabs working in 3 axes. These type of orthotropic or ribbed slabs have in Robot a particular way of being approach. Since Robot is indeed quite efficient in calculating these type of elements, but requires nonetheless of special considerations for us to obtain the corresponding reinforcement steel. And fortunately, this is a subject widely covered in this advanced level, so you can obtain the adequate design of such type of elements. Even more, we are going to subject these elements to critical loads. Namely, Robot won't just allow you to quickly perform analysis and calculations for validating the sections in your structure. Beyond that, is also possible to experiment the consequences of critical loads in our structure, thus obtaining the best possible design for all the structural components, in terms of both safety and economy. But moving on. Here we've our building now with the ribbed slabs in place. And we can then begin assigning all the load cases and combinations, and as you might know, verifying frame by frame, all the shear and bending moment diagrams, as well as deformations, stresses and even forces. And many aspects that we can easily observe when we exaggerate the scale of the deformations. When we do that, we can clearly notice the effect of the different load combinations, such as the one shown now. And in which, for example, we can observe a series of deformations taking place in the underground levels. Now, this is another interesting subject that we'll cover. How the static loads of the terrain influence the lateral walls of the underground levels. A very interesting subject indeed, which will as well give us the introduction to a geotechnical analysis. An analysis nevertheless fictitious, but that could very well correspond to real data, allowing us to analyze the generated static loads around the underground levels of this project. In this regard, we can now observe precisely what corresponds to the data of the geotechnical analysis, as well as the affected panels of the project. And from here, obtain the analysis that will allow us to create the design for the containment walls. But going back to the geotechnical analysis, we can also specify the soil inclination, since it's also possible to use this tool for embankments. Nevertheless, this is not one of the most impressive tools of Robot, since this, in its version 2016, give us the opportunity of simulating wind loads. And surprisingly enough, this is as simple as assigning both the wind speed and course, for the software to begin creating an analysis, producing all the wind loads, whether we're working with a close or an open structure, such a transmission tower. For example, here we can observe some of the wind effects. But furthermore, we can appreciate the simulation in real time, watching the corresponding torsions and deformations. Although obviously exaggerated by the scale, nonetheless, is also true that such scale allow us to easily notice those areas in which some critical torsion moments might present in our structure. But to continue, another matter we'll observe, of course, is the seismic analysis. In this regard, the software will allow me to obtain a modal analysis of the structure. Namely, that we'll subject this structure to a series of vibration cases, and observe their results. And to accomplish this, we'll use two methods. One corresponding to the lateral equivalent method, or specifically, we'll observe the accelerations over the project's centroids, in both x and y. But we're also going to perform a second analysis, in which to include the z-axis. For example, here we can also observe a real-time simulation, yet again, exaggerated by the scale. But that allow us to easily appreciate the structure's behavior, and where the main deformations are taking place. So from all these analyses, we'll review the structure frame by frame, observing all the different deformations, stresses, as well as shear and bending moments. Good. Once we've finished reviewing all the different stresses and forces that affect our structure, we could then obtain a complete and adequate analysis of all the components. But beyond that, in this course we'll put emphasis on working with completely new elements, such as ribbed slabs and containment walls. And furthermore, the punching effect over the slabs, as well as electro-welded wire mesh elements, how the software might calculate them, and obtain the corresponding drawings with the detailed folds, including its spacing and diameters over the slab. And again, regarding the subject of containment walls, we'll approach this into detail, performing all the corresponding set of analysis as well as the most adequate design for them. So at the end of it, we might obtain the calculation node for such design. These are then the subjects widely covered in this third course of Autodesk Robot SAP 2016, Advanced Level, for Buildings Design, Wind Loads, and Seismic Analysis. That, like all of our courses, you'll always have available on your computer. Watch as many times as you want, whenever you want, and with the help of our experts, through the Support Center. A group of professional engineers, always eager to help you with all of your questions, learning, and projects. See you soon.